Today we are very happy to have Professor Mark Benfield from the Oceanography and Coastal Studies School at LSU. Dr. Benfield came to LSU more than 20 years ago and is a senior professor here, and he does a variety of work with oceans and you will see, and also the river itself. And it's of course a very topical question, both because of the Mississippi River for us, but the whole concept and the problem of plastics, I'm sure you've been hearing about, and even into the oceans, this is a serious problem of plastic pollution. And so we'll hear about microplastics in the Mississippi River.
Thanks, Ravi. Well, good morning. Thanks for coming and spending some of your Saturday to hear about plastics. So I want to tell you about the research that we're doing in my lab in the Mississippi River. I want to tell you about the global plastics problem that we have in the world, and give you some examples of how it might be affecting our marine ecosystems. So this is the topic of my talk today. These are just some examples. You're probably familiar with most of these. I bet when you're at home or handling plastic items, you see these little logos embossed on the plastic, which tells you what kind it is. There are many more plastics than these, but these are common consumer plastics. So let's just start by thinking a little bit about our relationship with plastics. Now it's early in the morning, but I bet all of you have already interacted with a lot of plastic in your day. You might start off at Starbucks or CC's and you go get a cup of coffee, and the lid that they put on that coffee is made of plastic. And you get a stir stick, and it might be wood, but more likely it's a piece of plastic that you use to stir it up. And in fact, if you go to CC's, they even have these little lids, little plastic clips that cover up the drinking hole on the lid so that you don't spill your coffee. You might get thirsty during the day, or you go for a run and you want some water, so you grab yourself a bottle of Dasani or whatever your favorite or cheapest bottled water is, and you drink that down and the bottle is left behind. Maybe you take your own lunch to school or to work, and you put your lunch in a Ziploc bag. They're cheap. You can buy them in boxes of 50 or 100. Perhaps you wrap your food after you've eaten it with some Glad wrap or some Stretch and Seal or one of these PVC films. It's the weekend and it's starting to warm up, so it's time to start thinking about cutting our lawns, and maybe you use a weed eater. And so you take this spool of 50 meters of weed eater cord, and it's kind of amazing how it just seems to disintegrate and evaporate, right? And so that's all being pulverized on the pavement and on objects that it strikes, and shredding itself all over your lawn. Maybe it's lunchtime. Maybe after this lecture you might want to go get some fast food, so you get a soda and it comes with a plastic straw. It maybe comes in a plastic cup, and it comes with a plastic lid on top of it. And if you can't eat all of your lunch or your dinner and you want to take it back home with you, you grab a to-go container, which is almost always polystyrene foam or styrofoam, and take that back with you and take it out, put it on a plate, microwave it, and throw the container away. If you go shopping and you want to get some fresh produce, you can go and get a plastic bag. They're conveniently located throughout the store, and you can put your bananas or your bell peppers or zucchinis, whatever you want, in these bags, and then you put them in a shopping bag and you check out, take them home, throw the bag away. If you have a dog, maybe you use the bag for something else, and that's the end of it. If you wash your face, there's a good chance that you purchased a facial product that until recently contained tiny granules of polyethylene. These little plastic granules are used as abrasives, and so they are exfoliants, and you wash it off your face, and of course this stuff washes down the drain. Or maybe you purchased some toothpaste and it's got nice little blue sparkles in it. These are until recently polyethylene. If you go elsewhere in the world, they probably are still polyethylene. And if you order something, thank goodness if you order from Amazon now, the packing is now these inflatable plastic bags, but we all know the dreaded styrofoam peanuts So these things get all over the place. Most of you, I'll bet, drove here. And so you drove on a car that rolls on tires that are made largely of plastic. We think the tires are rubber, but in fact they're made of a variety of polymers as well as rubber that give them their durability and flexibility. So most of these plastics that you interact with on a day-to-day basis are very short-term relationships. You know, you're using these plastic items for a matter of seconds to minutes, and after that they're done. But these are incredibly durable materials. The great thing about plastic is its durability and its low cost. And so we can acquire these items for next to nothing, and we use them briefly and we discard them, or maybe we recycle them. We think they get recycled, and that's the end of it. Now, I don't want to start this talk by giving you the impression that I'm against plastic, because I'm not. That's my car. It's parked out here. It's mostly made of plastic. Look around this room. We're sitting on seats that are made of plastic. These countertops are made of plastic. My laptop is made of plastic. My watch, my phone. Plastic makes life possible. I sit on a chair in my office that's made of plastic. I produce photocopies on a copy machine that's made of plastic. When I fly around, I fly on aircraft that are largely made of plastic. So a life without plastic would be horrible. I can't imagine how primitive things would be if we had to craft all these objects out of natural materials like wood. It would just be impossible. So because plastic is cheap, because it's so useful, we use a lot of it. So this is some data from a recent paper in Science Advances. And this shows plastic production globally in billions of tons. And it's broken down into 3 categories here: discarded plastics, incinerated plastics, and plastics that are still in use. So plastics is still in use, about 2.6 billion tons. So these are things like that are in this room. These are durable products that last a long time. The incinerated fraction, a lot of these are recycled plastics. So these are plastics that are thrown out or recycled, and they are burned to produce heat, liberate the energy locked up in the polymer, and it's a convenient way of getting rid of them. But it's this fraction here, 4.9, almost 5 billion tons of plastic that is discarded. And this stuff is largely still in the environment. And if we look at consumption of plastic by different categories, a large fraction, this blue here, is in packaging materials. Go to the supermarket sometime, walk down an aisle, and start looking at how much plastic there is. We buy items that are wrapped in plastic. Inside there's yet more plastic. It's unbelievable how much plastic packaging we use. Order something from Amazon, piece of electronics, a USB stick, and think about how much plastic is involved in wrapping that product up. So it's really no surprise when we look at plastic waste by sector that one of the biggest increases in plastic waste by sector, let me get my laser here, is in this blue section here, packaging. Okay, so very, very high category. Consumer and institutional products as well as another one. Textiles, a lot of our clothes are made of plastic. We'll talk more about that. So my problem with plastic is not in terms of the structural materials that we use plastic for. I don't have a problem with this microphone or the video screen in front of me being made of plastic. But it's these things that we have this transient relationship with, this coffee cup lid, the plastics utensils that we have here, these lids, these soda straws, these little prepackaged condiments and things. If you fly on a plane, the cups that they give you for water or wine, that's a plastic wine bottle. There's a plastic wrapper for some snack. It's these things that we use so briefly. Go into my building and it's raining outside. They've conveniently got these umbrella bags for you, which you'll use briefly. And of course, this time of year, there's a large component of plastics that we use, we interact with rather briefly. And I know these things are like gold or treasure when they're in the air or on the float, but once you get them, or if you drop them, their value drops incredibly. So we get all this plastic, and I think we make ourselves feel good, because I know on Tuesday mornings I wheel out my recycling bin and I put it by the curbside, and a truck comes along and takes the stuff away. But the reality is, we used to be able to send a lot of our plastic waste to China, and China would clean it and sort it, and it was economical for them to reuse it. But we do a terrible job of sorting our plastic waste in the United States and Canada, and so it's contaminated with food, it's not clean, and the Chinese said, you know what, it doesn't pay us to take this anymore. So a large amount of our plastic that we recycle gets baled up, and it has to be stored somewhere. It's just put into these large accumulations of plastic debris, and it's piling up. But at least, you know, we have a mechanism to deal with our plastic, I guess. It's not like we're in the third world where we see these kinds of horror stories. So this is a lady, she's standing on the banks of the Congo River in the Democratic Republic of Congo, and she is surrounded by water bottles and other plastic waste. There are two cities. She's in Kinshasa. It has a population of about 12 million people. And right across the river is Brazzaville, which has a population of about 2 million people. They don't have any means of getting rid of their plastic. They don't have recycling programs. And so it just gets thrown out in the streets, gets thrown out into rivers, it washes down into the Congo River. And this is what the plastic waste from about 14 million people looks like over time. So definitely a horror story. A little closer to home, off Honduras. This is a video that was taken by a dive boat. Let me see, oops. Where's my video? Here we go. Honduras has the second largest barrier reef in the world after the Great Barrier Reef, and so it's a popular dive spot, and these people were out diving and they came across this mass of plastic trash accumulated on the surface of the ocean. So again, this stuff, they have no means of getting rid of it. It's convenient, it's cheap. All the products that they purchase in these towns and at these resorts are made of plastic, and when it gets washed out, it gets flushed into the ocean, and then ocean currents will cause it to accumulate where algae and seaweed and other things will accumulate, and this is the result. Just to give you an idea of how it's getting into the ocean, this is a video taken off Guatemala. This is a river in a town in Guatemala, and this is the plastic debris that's flowing down. I mean, it literally is a river of plastic, and that's all going downstream down into the ocean and getting into converging in places like the previous video. This was taken just a couple of days ago in Bali. I'd love to go to Bali. I'm sure you've all heard of Bali. It sounds like a tropical paradise. I'm not so sure I want to go to Bali anymore. They had a storm, and this is marine plastic that was washed up on the beaches of Bali. And it's just a phenomenal amount of plastic. That's just what's on the beach, so imagine how much is still in the ocean. So just a shocking amount of accumulation. And as it points out, the problem gets worse during the rainy season because that's when more of the plastic gets washed off the land. If we look at sources of plastic globally, places like Indonesia, Thailand, Vietnam, China, those are countries that are producing a lot of the plastic waste in that area. So at least we don't have stories like this, or do we? That's Baton Rouge. That's the little Bayou de Plantier that runs just past the University Lakes, goes under LSU Avenue at Stanford. And I visit this spot frequently, and this is what it looks like. And okay, it's not as bad as what we saw in Bali or in Kinshasa, But they have a population of 14 million people. We've got a population of 250,000 people. So I don't think we're doing such a great job here either. And you don't have to go far in Baton Rouge to see this stuff. So this is just along the edge of the bayou. You can see all this plastic trash. This is just along the edge of the university lakes. This stuff accumulates. This is taken in the street in South Baton Rouge. And again, just waiting for a rainstorm. This is on Thomas Delpit Drive in Baton Rouge. And notice this, a stormwater drain, all right? So when it rains, this plastic debris washes into the drain and gets into our wastewater system and into the Mississippi River. Louisiana prides itself in our wetlands and pristine natural areas. This is in a state park, and you don't have to look too far. There's plastic bottles floating around even in areas that we would consider wilderness. So plastic gets into our waterways, and then when we have a big rain event, it gets washed into the Mississippi River. And this is taken just in New Orleans, along the French Quarter, the edge of the French Quarter. And ultimately, it makes its way into the Gulf of Mexico. So we have a problem with plastic, and we produce a lot of plastic. And when I say we, at the moment I'm talking about Louisiana, but you'll see in a moment that I'm talking about the whole country. I want to talk to you now about a specific category of plastic, and that is microplastics. So we've talked about plastic in general, all those bottles, those are macroplastics. Microplastics are pieces of plastic that are defined as being 5 millimeters or smaller. So they could be about the size of a Mardi Gras bead, a standard Mardi Gras bead, down to something that you'd need a microscope to see, just something just a few microns in size. And so here are some beads. We collected these in the Mississippi River. They're on a penny, so you can see the word liberty here from the penny. So these are little micro abrasive beads that probably originated from personal care products. These are tiny little pieces of plastic that are floating around with the plankton in the river, and they're going to make their way into the ocean and ultimately, very likely, into our food webs. Those ones aren't because we collected them, but that's just a drop in the bucket. So let's talk about sources of microplastics. So obviously, one of the big categories is fragmentation of macroplastics. Now, how is it that plastics break down? Well, if you've probably all experienced, if you've walked around and you find an old piece of plastic, it gets brittle. And that's because plastic consists of polymers and compounds called plasticizers. And plasticizers give the polymers their flexibility and their physical properties. And so and you're probably aware of some plasticizers. Have you ever heard of BPA or phthalates? You might buy a water bottle and it says BPA free. So bisphenol A is a plasticizer. All right, so when you put these pieces of plastic out in the environment, under ultraviolet light, these plasticizers break down. Once you start breaking the plasticizers down in the plastic, it no longer has the flexibility and the malleability that it would have had, and so it starts to become brittle. So sitting on a street, a water bottle becomes brittle, a car drives over it, it shatters into a lot more smaller pieces, and these continue to break down and get smaller. So fragmentation of macroplastics is one source. Another one is bead blasting. It's kind of like sand blasting. You use high pressure air and a stream of tiny plastic particles, and this is used to blast away corrosion and remove paint and surface contamination from products. Ships will use it to blast off rust from the vessel. And so sometimes they'll use glass beads, sometimes they'll use sand beads, sometimes they'll use plastic beads. You can go to Lowe's and you can buy yourself a 5-gallon bucket of this plastic material, and this stuff sprays all over, can get into the environment. Plastic in its raw form comes in pellets called nurdles. These are the raw resin pellets. So if you want to make a Lego buys tons, millions of tons of nurdles of, say, polystyrene. They add color to it, they add plasticizers to it, they melt them down, put them in a mold, and out pops a Lego. So these nurdles, when they're transshipped from the factories that make them to ships that transport them across the oceans, to barges that transport them up the river, they're unloaded at factories down south of Baton Rouge and turned into various products. These nurdles get spilled, and so they get into the ocean. Tire wear is another big one. When you think about tires wearing down, laying a patch of rubber, you're really laying a patch of plastic. So over time, tires have a lot of plastic polymers in them, and these get, due to friction on the road surface, get worn down, and then when it rains, these little rubber particles or plastic particles wash out. Here's a big one: laundering of synthetic fabrics. So a lot of the clothing that we wear is made of plastic. It's made of fibers spun from plastic, so rayon, nylon, polyethylene terephthalate. These are common fabric plastics. Well, when you wash plastic clothing, it sheds fibers, and these fibers get pumped out of your washing machine during the wash cycle, the rinse cycle. And you know how much lint accumulates in your dryer. Well, even more lint gets washed out of the washing machine. These are tiny particles. They make their way into our water treatment plants, and a lot of them wash into the river. And even if they are collected in the sludge, the sewage sludge, which is often sold as fertilizer after the fact, then it rains and it gets washed out of the sludge and into our waterways. Personal care products, so this is some Neutrogena facial scrub, and each one of these little dots in here is a polyethylene bead. And so these things are being phased out now. As of last year, they shouldn't be available in personal care products, but you may still find them in stores. They're supposed to use other materials. And then a lot of the paint that we use in our society is actually made of plastic or based on plastic films. So paint flakes are a huge source of plastic in the environment. So let's take a look at these microplastics from all these different sources. These are some pictures I took in my lab under the microscope. These were microplastics we collected. And I want you to look at these. There's a couple of things that are apparent. The first is, these are small objects. I don't have a scale bar on here, but they're just a few millimeters across. And they have a large surface area relative to their volume. If you take a ball, a marble has a large surface area relative to its volume. The surface area of a sphere increases as a square function. The volume increases as a cubic function. So the bigger you make something, a bowling ball is going to have a much larger volume relative to its surface area than a marble. So when you get down to small things like this, you've got a very small volume and a pretty large surface area. Next thing I want you to notice is how pitted the surface area is. There's all these little nooks and crannies which further increase the surface area, and you can see this thing is breaking down. This is because the plasticizers in it are degrading due to ultraviolet light, leaching in water, and so this thing is continually shedding other pieces of plastic. Here's a flatter piece, and you can see the cracks in this. It's breaking down. There are little fissures. And again, large surface area to volume. This is a piece of styrofoam. This is a tiny bit that might have been a cup at one time, or a styrofoam food container. And again, look at the surface area here. It's just got all this surface area. Why is that surface area important? Well, if you put water on plastic, plastic has a surface chemistry that we describe as being hydrophobic, or water-hating, water-repelling. And so if you put water on a piece of plastic, it beads up. And that means that because it's hydrophobic, anything that is polar, a polar molecule that has a net positive charge at one part of it and a net negative charge elsewhere, is going to be repelled. This is water. Water is a polar molecule, so it gets repelled by the surface of the plastic. But many organic compounds are nonpolar. So things like herbicides, pesticides, polyaromatic hydrocarbons, these DDT, PCBs, these organic pollutants are nonpolar molecules, and they tend to stick to hydrophobic surfaces. So this plastic has got a huge surface area, and it acts like a sponge, and all of these organic pollutants in the water will attach to these little plastic particles. And so I was talking to an environmental reporter down in New Orleans, Travis Lutz, And he said, so these things are like Ubers. And I said, yeah, that's a great analogy. These little plastic particles are like Ubers, and they're carrying all these nasty little passengers along with them. All of these organic pollutants are on the surface and inside in cracks on these plastic particles. So they're a vehicle for transporting this crud in the water. And the longer a plastic particle is in the water, the more this stuff will attach to it. And so then when an animal eats a piece of plastic, it's not only getting the plastic, but it's getting all the crud, all these organic pollutants that are on the surface of the plastic as well. But why would an animal eat a plastic particle? I mean, what possible reason would something like this be consumed? Well, it's interesting. It doesn't take very long, a matter of hours, after a piece of plastic is put in the ocean, and it gets colonized by microbes, bacteria and fungi. And these bacteria and fungi synthesize a compound called dimethyl sulfide, DMS. Dimethyl sulfide is produced by phytoplankton and by a lot of marine organisms. And it gives them the smell and the taste of something that's good to eat. Seabirds will locate plankton and small fish by the smell of dimethyl sulfide coming from the water. And so this little piece of plastic rapidly starts to smell and taste like something that's good to eat. And so it can be mistaken for some natural item. And in addition, the colors and the reflectivity of a lot of these particles, if it's a piece of glitter or something like that, can look like something that's attractive. We know that there's a lot of microplastic in our oceans when we look at beach surveys. So we saw that beach in Bali that had all the garbage on it. Well, in beach cleanups around the world, and these are just data from average beach cleanups in the United States, we see a lot of these single-use items washing up. So we see things like foam, styrofoam, cigarette butts. They can often be the most abundant plastic debris. And we don't think of cigarette butts as being plastic, but the filters in the cigarette butts have all these plastic fibers in them. And next time you're in your car and you're at an intersection where there's a traffic light, take a look at all the cigarette butts that are on the ground there, because people who smoke seem to, not all of them, but a lot of them seem to think they can toss these things out in the environment and they break down and go away. Little plastic fragments, food wrappers, lids, bottles, there's all kinds of debris that we see. And just to show you what this stuff looks like, I'll pass around as a little show and tell. This is from Elmer's Island. This is a beach down this was actually in Europe, in the Netherlands. So they've got a similar problem. We're looking at cigarette filters, we're looking at foams, small pieces of plastic, plastic bags, plastic bottles, straws, lids. All this stuff is a common plastic. So what are the impacts? Well, we've probably all seen the high-profile impacts when you see sea turtles choking on plastic bags. Again, why would a sea turtle eat a plastic bag? Most sea turtles eat jellyfish. And a plastic bag floating in the water covered with bacteria that are producing dimethyl sulfide, that looks a lot like a jellyfish. And I can tell you that a lot of these sea turtles eat Portuguese man-o'-war and jellyfish that have really powerful stings. That tells me they don't have much in the way of taste buds. So they'll start eating on this plastic bag and they can't really taste that it's not something good for them, and it can block their digestive tracts. Here's a dolphin that has swum into a plastic bag and it's almost occluding its blowhole. So it's that animal's at risk of asphyxiation. Many seabirds forage at sea. Albatrosses are good examples. So this is a picture from Wake Island, a big albatross rookery. And this is the carcass of an albatross. And all that's left are the bones, a few feathers, and what was in its stomach. And it's all these plastic objects. And these birds forage at sea, they come back, they regurgitate what they've eaten and feed it to their offspring. And so their young die. And there's pictures of young birds, carcasses of young birds that have lighters, multiple lighters with the fluid, the toxic hydrocarbon in the lighter still in their stomachs. And of course, things like seals and sea lions that are entangled in plastic nets. So these are the obvious impacts of macroscopic plastic in the ocean. But what about microplastics? So let's start with our different sources of microplastics. They're continually, through photooxidation and mechanical breakdown, breaking down into smaller and smaller fractions of microplastic. So the numbers are increasing, and the smallest fraction are the most abundant. We know that persistent organic pollutants are adsorbing onto the surface of these. And so when these get ingested by marine life, by zooplankton, and then zooplankton are eaten by larval fish are eaten by bigger fish, the concentration of these organic pollutants increases, and we call that process biomagnification, the increase in a toxin as we move up a food web. And mercury poisoning is a classic example of this. Mercury will be present in low concentrations in zooplankton, and as you move up to top predators, the concentration of mercury can become very, very high. So we know that it's getting into these organisms, we just don't know what the impact is. It may be chronic toxicity, it may translate into subtle changes in their growth rates. We know that an animal that has a stomach filled with plastic is not getting nutrition from that plastic. Moreover, it may feel full, and so won't feed as much. And so there can be mechanical blockage of the digestive tract. And so that can translate into lower growth, perhaps mortality. We know that these organic pollutants are accumulating in these animals, and they may have effects on their ability to swim, to evade predators, to find food. So there are ecological impacts, but unfortunately at this point we don't really know the extent of those, and that's an important question. We also know that these plastics are continually leaching out phthalates, bisphenol A, and other plasticizers, and these are getting into our water supply, and we're drinking them. Why is that a concern? Well, phthalates and bisphenol A have many chemical properties that are similar to natural hormones. So they can act as endocrine disruptors. And so the body treats them as a natural hormone. They can bind to sites where normal hormones can bind to, and this can cause endocrine problems. And so there's a potential issue with these things causing problems. In the Philippines, for example, they light a lot of their fires with plastic bags. It's a cheap source of easily combustible material. And so people breathing the smoke from those plastic bags have much higher incidences of cancer. And so a lot of these compounds from plastics are potentially associated with health problems, but again, we don't understand this very well at all. And so ultimately these translate into economic impacts. If marine populations are negatively affected by the plastic, if human health is negatively affected, then this will translate into unmeasured yet, but probably real financial impacts. So I want to return back to the oceans now, and I want to talk about some research that we did. Not a lot of work was being done on microplastics in the Gulf of Mexico. There was one study that had looked at beaches in Mobile Bay and found some microplastics in them. In 2015, I was teaching an undergraduate class here at LSU, and I was given time on one of the big research ships that is operated by the state of Louisiana at LumCon, a lab down in Cocodrie. And these are some of my students. We went out on the RV Pelican, and I had the ship for 24 hours, so I thought, well, let's go out and collect some samples and see if there's any plastic out there. And sure enough, there was. What we did was we went to 4 stations here south of Terrebonne Bay. There's the Birdfoot Delta. And we went into these areas here, and we sampled with a net. I didn't have a net that was designed to catch plastic, but I knew that plastic floated. A lot of the plastic floats. It has a density less than 1. Some of it sinks. So we rigged up this net with some floats on it, and then we also deployed this net without the floats down to about 25 meters. So we kind of started at the surface, went down to 25 meters, pulled it back up. And so we had both surface samples and what we called bongo samples. And the moment we pulled the nets up and we washed the contents of the nets into a screen, into a sieve, you saw all this color. And it was clear that there was a lot of plastic there. So these are just a collage of some of the examples. These are fragments. These are fibers. These are films, little flattened pieces, and these are little micro beads. And each one of these lines here is 1/10 of a millimeter. So these are pretty small particles. We also collected water bottle samples. So we took a system, we lowered it into the ocean and opened and closed bottles to collect samples of water at different depths. And when we looked at those, we found really high concentrations, mostly of fibers. So to show you how small these things are, these are single-celled diatoms. These are single-celled algae. This is a single-celled amoeba called a radiolarian. But look at these little fibers. These are almost all likely from fabrics that were washed, the laundry lint. So I was curious, how high were these concentrations compared to other places? So these are irregular fragments, fibers, beads, and this is the total. This is from the bongo nets where we went down to 25 meters. This is from the surface samples. And you can see we're at about 10 particles per cubic meter. That's 1,000 liters. And here we're about 6 particles. So that doesn't seem like that much. But when we compare that to the Great Pacific Garbage Patch, they're down at about a little over 2. The North Atlantic Central Gyre, down pretty low. The Northwest Mediterranean, about 1/2 particle per cubic meter. We are really high. So then I started wondering, well, where is it coming from? Because all of you know that we don't have a high population density along our coast. People don't, there's a few camps, there's Homa, Morgan City, but it's not a high population density area. So where is it coming from? Well, the obvious candidate was the Mississippi River. The Mississippi River drainage basin covers a large part of the continental United States and a little bit of Canada, and there's 100 million people living in the Mississippi River basin. 100 million people produce a lot of plastic. Think about all the plastic that came from 14 million people in Brazzaville and Kinshasa. So we are getting 100 million people's worth of plastic. It's coming down the Mississippi River, flowing past Baton Rouge, New Orleans. It's coming out into the Gulf of Mexico. Due to Coriolis force, we know that currents are deflected to the right of their normal trajectory. So it comes out here and it makes a right-hand turn, and we were sampling over here. So we were in the plume of the Mississippi River, and that's likely where the plastic was coming from. So our focus has been since then on the Mississippi River. We got some funding from Louisiana Sea Grant, and we started a program sampling at 5 stations that spanned Baton Rouge and New Orleans. We sampled upstream of the northernmost wastewater outfall in Baton Rouge, and then just below L'Auberge Casino, below the lower outfall. And then we sampled near Davis Pond, that's right near where the 310 bridge crosses over the river, and down near Carnarvon, which is near Belle Chase Naval Air Station down here. So we sort of bracketed the city of New Orleans. And what we would do is every 3 months we'd go out with this net. It's called a manta net. It skims along the surface. It's got a flow meter in it, so we know how much water is going through it. And we would also pump samples from the river with a pump and filter them through a kind of water filter that looks like the thing you might have in your house or your camp that would collect things larger than 10 microns. And we'd basically cross the river 4 times. So we'd go across and we'd take a sample. We'd go from the other bank across, and we do that 4 times, get 4 replicate samples, and we do 2 duplicate pump samples. We collect about 100 liters of water. And what do we get? We get lots of plastic. This is a typical sample here. We've poured it out onto a screen. Here it is in a jar. There's a bottle cap, a fragment, a bead. There's just all kinds of little pieces of plastic in here. So then we have to pour them through a sieve, separate them into different size fractions, pick out the plastic. And here's another sample. This sample, I can tell you, is from New Orleans because I can see these nurdles, these little round plastic pellets in here. We don't tend to find those in Baton Rouge, but down in New Orleans we get a lot of nurdles. Between Baton Rouge and New Orleans we have an area nicknamed Chemical Alley. There's lots of plants along the river that use plastics or produce plastics, and so I suspect they're coming from there. So we're still working up these samples. I don't have any numbers for you yet, but we're trying to build up a picture of what the seasonality of plastic flux in the river is. it's got some relevance to the coastal master plan. So you've probably heard of Louisiana's coastal master plan. This is a grand project to try and rebuild our coast. And central to the coastal master plan are things called diversions. Diversions are basically siphons from the Mississippi River that allow water from the river filled with sediments to be diverted into our coastal wetlands. As the water slows down, the sediments settle out, builds new land, and hopefully will offset some of the subsidence and erosion losses that we're having. This is the intake to the Davis Pond diversion. So this is on the river side. So obviously a lot of wood. Water is flowing out through subsurface openings here and into a canal and down into Barataria Bay. But look at all the plastic debris that's in here. So my postdoc and I, Matt, we wanted to take a look at this. So we went to the Davis Pond diversion. This is on the river side is over there. This is where it flows out. We put our net in here and we streamed it in the current. It's an amazing place to see fish and alligators. Like there's some huge, that's an enormous alligator gar that was surfacing in front of our net. So we would collect samples there. This is the discharge rate from the sample. And at one point, we asked them to bump the flow up a little bit. So they did that. And this is just a short video. You can see all the crud coming through. But look at, there's plastic everywhere in here coming through here. And in one 15-minute sample, we collected all of these nurdles, all of these fragments, these foams. This is from one 15-minute sample. This is the plastic that we got out of this diversion. So my concern is diversions are great. They're probably a good plan for building land, but we need to start monitoring how much plastic we're transferring into our estuaries where marine life can eat it. And this is the implication from that sample. This is the flux in numbers of particles per hour. So for the 500 micron to almost 2 millimeters, half a millimeter to 2 millimeters, 2 to 4 millimeters, and greater than 4 millimeters, these are the numbers. 8 million per hour, 5 million per hour, a little over 2 million. We're talking about transporting 388,781,515 particles on average per day out of this diversion. And the flow rate, when they bumped it up there, was very close to what the average daily flow rate is for this system. Why does that matter? Because when we start looking at the stomachs of fishes from our estuaries, this is what we see. This is from an Atlantic bumper. It's a small zooplanktivorous fish. It eats little particles, zooplankton. And its stomach was filled with these fibers, all these fibers here, and this big piece of plastic. And that means that people who eat fish from the river, like this gentleman, I met him, he fishes down by the Mississippi River Bridge in Baton Rouge almost every day, and he eats the fish that he catches. Well, if these catfish are consuming plastics and the chemicals on those plastics are getting into the tissue of fish, they're getting into this man or his family. And so that's a source of concern. One of the biggest fisheries we have in the Gulf of Mexico is for a fish called the menhaden, and they grind those fish up whole, and they feed them to pigs and to poultry. They express the oil from them and they sell them as omega-3 fatty acid tablets. Well, we know that menhaden eat a lot of plastic. They're zooplanktivorous fish. And so they are potentially, we're feeding that plastic back to animals that we eat, or we're eating the oils. So now in my lab we've got some new instrumentation and some new approaches. This is an FTIR microscope. It stands for Fourier Transform Infrared Spectrometer. And basically we take these little particles, put them under there, shine an infrared laser on them, and we get a reflection, a spectrum back. And we can say exactly what kind of plastic it is. So we confirm that the particles are plastic, and we can say what kind they are. We started a pilot project to monitor, remotely monitor what's going on in the Mississippi River. And this is a trail cam. Those of you who might hunt may be familiar with trail cams. Trail cams are what hunters use to monitor deer and other wildlife. It basically is a remote camera, and it takes a picture when anything moves in front of it, or you can set it to do time lapse. And so this is a trail cam that we monitor, we set at the Water Institute of the Gulf to try and get some video. And sure enough, I'll play you this video clip here. this little video clip is of just of the water, and you can see plastic that's fluxing through there. So that was one approach. Unfortunately, people kept messing with our cameras. They'd go out on the dock and they'd say, well, even though we had signs and everything, they'd aim it at the Mississippi River Bridge. So we've got a new approach now. Just give me a second. So now, instead of using, one second. Go back. Instead of using the trail cams, we're going to start flying over the Mississippi River. And I've just got to connect to this thing. Okay. So now we use little drones like this. This is our training drone. This is just a little Rise Tello. But these things are great tools for learning to fly a bigger drone. And so a drone like this is what took this video here. I took it out to Bayou de Plantier. And, oops, go back. And just started flying along the edge of the bayou to see what sort of image quality we could get. I have a much bigger drone. This thing's called a DJI Spark. It's got a range of about a mile, and we're going to start using that drone system to fly across the Mississippi River. So little drones be a great high school science fair project. You could use them to survey plastics in the bayou, but the bigger drone is definitely something that we want to explore. Now, this is Mardi Gras season. Let me land this thing. That's a $79 drone. I mean, it's pretty amazing the technology that's at our fingertips now. But now we've got Mardi Gras season approaching, and last year the city of New Orleans pulled about 50 tons of Mardi Gras beads out of their sewers. And so I want to get out over the river after these parades when we've had a rain event to see if we can document some of that. So this was yesterday. Tiger TV was doing a feature on it. So this is above one of the LSU athletic fields. It's a picture taken from our drone. So we're going to be using this system once we're comfortable flying it, so that when we can get a rain event, we can document how much plastic is fluxing. I want to end off this part of the talk and just wrap up by saying that we have become so accustomed to plastic being part of our society that we take it for granted. We don't even really see it anymore. And you know, you've probably seen a show called Fear the Walking Dead. And so the set designers in Fear the Walking Dead, this takes place in post-apocalyptic LA, and the city's abandoned except for the zombies and a few survivors. They were asked how they transformed LA into a post-apocalyptic wasteland, and their answer was, we just picked up some of the trash. So trash has become an indicator of human life, of society. And you know, if you don't have humans around, you're not going to have all this plastic debris. So what can we do? So that's me when I was a little kid on Cape Cod with my bucket, and I lost that bucket, but I guarantee you the bucket is still out there. It's just in millions of little pieces. It's broken down. Those are my sons. They like going to the ocean. So what can we do? Well, there are some things that we can do. We can invest in reusable shopping bags, in stainless steel straws, in reusable coffee cups, reusable water bottles. All of these things are going to reduce the amount of plastic. And if people in the Mississippi drainage basin, 100 million people take these steps, it's going to result in a significant reduction in those single-use plastics. Don't bag your produce when you go to the supermarket. You should wash it at home anyway. People have been handling it. It's been covered with pesticides and herbicides. When you go to a restaurant, request no lids or straws when you order a beverage. It's not the server's fault when they bring you a straw. That's just reflex. It's muscle memory. They've been so conditioned to do it. Just ask for it. You don't need it. If you're going to be going somewhere with a hot cup of coffee, get a lid, yeah. But if you're not, you don't need it. You can buy filter bags to put on your washing machine outflows. So a thing called Guppy Friend is a brand. Go on Amazon and there's a variety of different ones. Read the labels on your personal care products so that you're not buying products that are using plastics. Pick up litter. It sounds trite, but if you pick up litter, you're actually removing it from the environment before it gets into the river and into the oceans. And there's a great app, you can get it on the Android and the iPhone store, called Litterati. And you take a picture of your trash and it geotags it, and you can then search for where other people have found trash in an area, what kinds, that sort of thing. Volunteer to participate in beach or lake or river cleanups. And in fact, there's one coming up on Saturday, March 9th. The Knock Knock Kids Museum is having a lake cleanup day. Bio Lafourche is having a cleanup day on March 23rd this year. So that's another area that can use it. We can learn from other places. We can learn from cities like Toronto. They're not perfect, but they have a much more extensive recycling program than we have. And if you go on the subway, they've got posters about what you can do with different kinds of plastic. They even have things, I saw one, how do you recycle a hockey stick? I mean, that's a typically Canadian problem. And you can see this trash can out there has got more recycling slots than trash slots. If you go to a lot of the coffee shops, they won't automatically give you a lid unless you ask for it. There are paper straws. When I was in Margaret River, Western Australia, I went to the farmers market and they had banned plastic bags, but they had for purchase at a nominal price reusable bags. In New Orleans, they're putting these systems called gutter buddies out. They're little dams to prevent the beads from getting into their sewers. So I would just end by saying that we have an invisible problem. We don't notice it, but we've got all this plastic. It's getting into our waters. It's getting into our estuaries and our coastal oceans. It's almost certainly getting into our marine life and ultimately may have some negative effects on us. And I want to thank you for your attention. Thank you.
So as usual, I think it works better if those of you who have some questions come up and ask the speaker directly. And also those of you who are signing up sheets for your high schools, please meet our graduate students and they'll help you with that at the counter. Thank you all for coming and I hope we'll see you next month. Thank you very much.
Thank you.